Hello everyone and welcome to a new ecosystem session at the podcast Hackathon Latam 2022. Today we have a great project from the Polkadot and Kusama ecosystem, Unique Network. Unique is a scalable blockchain for marketplaces, games and dApps with advanced features built for Polkadot and Kusama. Unique won the 14th Polkadot action and will be connected to the relay chain of Polkadot until April 2024. So welcome Georgi, project manager, Sergey, developer team lead, and Philip, developer relation managers. Welcome guys.
Hi.
Hi guys, I will start with hackathon. Nice to meet you, and I'm really glad to see you on this hackathon. Let's move on, and I will share my short part of presentation to present a little bit information about Unique and about the plan of this hackathon. And after that, I will give a floor to Sergey, and he will make a hackathon for you where we will make a new collection and other stuff. So yeah, I will describe it right now in 5 minutes. So can you help me? Do you see the screen?
Yep, you're presenting.
Yeah, thank you. So yeah, a little bit about Unique. So yeah, as we talked before, Unique is a parachain based on the Polkadot ecosystem parachain, and it is optimized for NFTs. You can find, I will share this presentation in chat in Zoom, and you will be able to open it in your browser and yeah, so you can find more information about Unique Network by this link, and a little bit more information about Unique. So we have a free blockchain, but first of all, it is a testnet. We call it a PAL, and we use it just for testing new features of our blockchain. And you can use it too for your features, for your services, for your products. But you beware, please, that you can data from the test. Sometimes we reload it and delete all data. Also, we have a canary net. The name of this canary Quartz. So it's a stable net, and we use it to a final, not well test, but we're using for be sure that everything is okay. You can use it free, not free, I mean you can use it and you can deploy products on this blockchain, and don't worry about your data, you will not lose it, but sometimes we have a maintenance time on this chain. And finally, we have a mainnet. It's called Unique, and yeah, it's a production-ready blockchain, and we use it for our products, and we using our clients using it for their products. So it's about our blockchains. About our products, we have a marketplace to sell, trade, buy NFTs. We have a scan to take data from our blockchains, and we have a wallet where our users can create a wallets and transfer their NFT and our stuff.
I'd just like to jump in at this point and say that Opal tokens are free to use. They have no value. You can get them from a faucet, and we'll be using the testnet, of course, to demonstrate everything here. And this is exactly what its purpose is, to test all your samples and use that money. This is why it was mentioned that sometimes it can be reset and so on. There isn't any production level of anything that should exist essentially on that network.
Yes, and I will share a link in this presentation to the Telegram bot where you can take Opal for your service. So move forward and a little bit about the hackathon and the goal of this hackathon. So we want you to create any service for mass minting on Unique. To mint thousands of NFT with one request. It doesn't matter what it will be, web service, browser extension, script, and so on and so on. You can choose your own way, but the main goal, we want to find nice solution to mass minting on Unique. And exactly on this workshop, we will show how we can do it by our SDK. So move forward and let's talk 1 minute about the plan of the workshop. But first of all, we will, Sergey will help you to generate images from the pieces. After that, we will upload this image to IPFS. After that, we will mint the collection. In second point, we will make a mass minting for NFT by our SDK. And in the last point, we will mint nested NFT. Nested NFT is our new feature of our blockchain. It means that you can put within one, you can put one NFT within another NFT. So I will share the link of this short presentation to the chat. You can find all links for the examples, for the documentation, to the PowerBoard on this page. So use it. Yeah. And I give the floor to Sergey. If no one have question right now, Sergey, you can start the workshop.
And just before Sergey starts, I wanted to say one thing. As Sergey will be presenting, you will see very interesting things about how certain aspects of the library and the SDK are used, especially the SDK that we're using to mint, to create things on the blockchain. So there's essentially the thing that the part of programming that handles the creation of the entities, and there's the part that communicates with the blockchain. Keep an eye on that. Sergey will go into those details as he presents.
Thank you. So, Sergey, I think you can start.
Hi all, welcome to a hackathon. Today I will show how to generate images for NFT, how to upload it to IPFS service for use it those images for generate NFT tokens, and how to create collections, create tokens, and nested token to another one. Let me share screen. Okay, and let's start. First of all, we should create a new directory for our scripts. I called it workshop. And we should go. And for easy way for develop, we need code editor. My choice is Visual Studio Code, but you can choose another one, your lovely code editor. And for generate images, we need pieces of images for generate many variants of NFT. I have a bunch of pieces, and now I copy it from another project. Oh, sorry. It should be copied. And let me show what that piece is. Increase size. How can you see that brow, eyes, nose, mouth, and another piece of head? We can generate many variants of faces using that piece. Oh, now we're ready to create our first script, generate images TypeScript. For our example, I will use TypeScript because it have a good code computation, and our library have a lot of type definition for help developers to develop with our tools. It have many interfaces for arguments, for returning data, and other things. We should install TS node. And I have a draft of that script, and for the same time, I'll just copy code.
So we'll copy and paste it just to save time, not having to type it. But Sergey will go through all the relevant elements. We're copying and pasting it in segments so you can follow through.
For generate images, we are using external library called merge image, and we should install it. And for describe pieces of face, we should create a file with description. I called it attribute. And copy it from draft.
So this is essentially a attribute classifier of all the images that we've got there, that are the elements of the final NFT.
Yeah, and position of elements mean index in piece name, but it started from 1, not from 0. It's a legacy from another project.
The forever question. Where does the index start, from 0 or 1?
For start script, we can use npx to run TS node in node monolith environment, or can add script definitions to our package JSON scripts. Generate images and TS node and generate images TypeScript. What happened in this script? We defined 3 constants. First, mean path to directory with images. Second, mean output folder for generated NFTs. And third, it's a metadata file. It file will be a content path to generated image, and metadata what used for generate image. In this piece of code, we are composing all attributes. It's a Descartes
multi-attribute kind of error.
Yeah. And after that, we have face descriptions, and we can generate it using merge image library. And we're ready to try it.
So the metadata will finally actually have a kind of a structure of the finally composed images in a textual form and the metadata layout.
Yeah. Oh, something going wrong because we missed type definition for library merge image.
Oh, I love these errors. And I love when you fix them. So keep an eye on this.
How can we see console output logged path to generate image, and we can open that directory for see that images.
And they're being generated live. Yay.
For all used pieces, we have 405 variants of faces, but we took only 20 variants for generate because it took a lot of time. We can see it in end of script. We should slice of face attributes from 0 to 20. And after generate image, so we have a file with definition of image attributes. You can see it on my console. It's path to image and a bunch of attributes. Attributes name and attributes value, like head, eye, brow, and etc.
It goes without saying, we're not going to be generating 10,000 of them. There's only 20 of them we're doing for this demonstration. But this is just a limitation we're setting for making this very quick and easy to present. You do the 10,000 if you want to. There's no limitation there.
Yep. You can remove that piece of code and use all faces for generate faces.
So this opens up a question of how are you going to manage, and this is part of the assignment. What's the idea of how can you manage generating what variations? Is there ways to kind of calculate the rarity during it? So there's a lot of questions that are being lying behind this little move here, which is part of the assignment as well, which you can integrate in any way you find interesting.
Okay, and after generating images, we are ready to upload it to our IPFS service, and we should create script for it. Upload images TypeScript and copy it from draft. In this script, we are using form data library for but our files for form data to upload to service by post query, HTTP post query, and node fetch library to run HTTP query, and MIME types for defined type of files. Where is it? MIME. Oh, yeah. It means because we can upload any type of files. In our case, we uploaded PNG, but it may be JPEG, GIF, or something else, and it will be uploaded correctly. We should install dependency from data. And not fetch. Oh, and MIME text. After that, we are adding our script to script definition. Upload images. Not use not upload images TypeScript. Depends was installed, and we can run it. Upload images. Same things. We are using type definition for MIME types library. Oh, it's error about modular resolution. We should in our version, we should use in our version of not fetch. How I know it's 2.62. Let me check.
So this implementation relies on a bit older version of Node Fetch.
Something going wrong. And that. Oh. And type definition for not fetch. Something going wrong. Oh, I missed a part of scripts. Copy it. Maybe or not. Okay, where is it? Oh, it's an old version of upload. That's new. Sorry, guys. Now we see a log about file uploading. We see uploading image path on the disk and path to uploaded file on the IPFS file system. We can copy that URL and check it in the browser. It means what file uploaded correctly and displayed correctly, MIME types is correct, and everything is fine. All 20 files was uploaded, and we can check NFT's metadata attribute file because we save path to file in NFT metadata file. It's a full path to image and the IPFS seed. It will be need to create collection and create tokens. In case of create tokens, we are using IPFS seed. And we are ready to demonstrate how we do it.
So essentially, this is what we were talking about, that this part is going to get constructed, because essentially you could do this by hand if you were making one or two, one collection and a few NFTs, but getting it generated is the important part of the next step, which is actually creating them on the blockchain. So this metadata is a very important part of it.
Our next script is a script about create. Oh, sorry, do not create tokens. Next step should be create collection, because we can't create token if collection does not exist. Create collection script. Create collection draft and copy it to our project. So many spaces. In this script, we are using our SDK tools. In this case, it's called Substrate Client, and we should install it.
So this is the sweet part, the SDK going into action.
And for getting our account by mnemonic, we should library unique NFT accounts, and we should install it. Oh, sorry, not finished yet. Okay. In import, we can see attribute type and collection scheme name. That enums contain type of attribute. It may be integer, float, boolean, string, and etc. You can download our library and check it in the type definition, and or you can see it our documentation. And collection scheme have three value as unique, our old scheme, and ERC scheme. For get account, we should know mnemonic. Mnemonic is a phrase like password. We should keep it in secret. And
so it's the 12-word phrase that you get when you generate an account, either through the unique wallet or the Polka.js extension. It's that mnemonic, that exact one.
Yep. In our cases, we are using Opal, a unique network, and how can you see? We have collect name and description and cover picture. What is cover picture? It's a set of uploaded image. We can use one of a set from uploaded image, maybe this one. Place it. And URL template. URL template using in our blockchain for creating tokens. In stage of creating collection, we define template with infix, and that infix will be replaced by a PFS seed from tokens, and it should be defined.
Oh, one more thing, the mnemonic that we're talking about relates to the account in which the actually collection is being created. So this is an important thing. We forgot to mention that concept, but there is definitely an account to which you are creating and crediting the creation of the collection and the tokens.
We can see some small documentation about create collection method. That link save it in a piece of code, and we can open it. I will put it to our chat. Where is it? Maybe not. What's next? In main function, we are creating signer from mnemonic using our keyring provider from library, and instantiate SDK by chain SRL and signer. Signer needed for SDK for sign transaction, and we need address, sign address for create collection and token. It use it in this place. Token prefix can contain alphabets and have max length in 4 symbols, and will be a prefix of token. Name.
Alphanumeric, I think 4 alphanumeric characters is allowed.
Yeah. We are using our new scheme. It would call it unique. It provides to us URL template, attributes, and some other new functions, and we should use it. Attribute scheme contain the object with where k is a number and k of contained object name means what that attribute name, but underscore mean what it's default value. Default value for multi-language support. Type type definition. Optional means what that attribute should be required in token or not. Array means what attributes in tokens may contain more than one value, and enum values contain option of value. In this example, it's male or female for attribute sex, or in our documentation we can see in our attributes more better for our case because it contains literal head, normalized, standardized, and other attributes from face.
So this is actually the schema constructed through. So we can call this. That's a very good part there. So this example that Sergey is showing here is actually the way it's being laid out in the schema. All that we've been doing now in constructing and organizing the elements of the face, classifying them into certain categories and so on, they get represented in this very special way, which is the formatted attributes, internal formatted attributes form, which Sergey is trying to display here. And the one note again, please remember that is there is a multi-language option there. The underscore that's being used as the default means for all languages, but you can add for English, Spanish, and more languages if you want to have different definitions pertaining to the same attribute. I think in Spanish it's sexo. You can correct me later. I mean, the Spanish listening people can help me there.
I don't know
With
how
the definition, yeah. Okay, let's go on.
Okay. Next parameters is permissions. In next our step, we will create nested token, and for do it, we should permit it. And in this, but by this flag token owner, we are allowed to owner nest one token to another.
So essentially, if we miss out this part, then the token will be a classical token, an unnestable token. But if you include this and declare this, then this allows us in the next step to play with nesting the tokens.
Yep. And for our collection, we can define admins, and in this place we can allow to admins. Competitions aren't working. Maybe we can see in this place. No, permission, error, permission, collection permission. I will show it later because in my editor tab definition working incorrectly. I don't know how it right. Something like admin, or something else. It allows to administrator nest one token to another like owner.
We'll get into that. Yeah, we'll get into that later. It's not important. Just a note being that this is the place where you would declare the administration of a token, which is necessary if you want to nest tokens from different collections. It needs there's a certain condition under which this can be done, and this is the proper place to set the ability of this inter collection nesting and so on. We'll get into. You have those details in the documentation explained quite in detail on site. Yeah.
In this case, we are not writing attribute scheme by hand, and we are generating it from attributes. In this piece of code, you can see how it works. And we are ready to start it. Oh, we should add it to scripts. Create collection. Yes, node, create collection, TypeScript. And run it. What's going here?
And the reason why we're doing this because to create a collection on the blockchain expects data to be organized and prepared in a very specific way to be properly, deployed on the blockchain. So this part of the program prepares it for creation of the collection on the blockchain itself.
We skipped type definition for our Opal and Quartz network, and we should install it. In log, we can see how SDK client trying to connect to our blockchain, connect, disconnect, and check some things. And now process of creating collection is running. Yep, our collection was generated. This ID is 3004.
1404, and take a note of that. You'll need that. So once you get this output, do take a note of the number of the collection ID. This is where it will be displayed. So 1404 is the number we need to remember because it's very important for the next steps.
Yep, this is our web application. We called it Scan. Reading data, all data from blockchain, but it has some time lag, 2 or 5 minutes for reading. And after the reading was completed, we can see our collection in this refresh page. Oh, it's our collection without tokens. You can see that ID.
Yep, 0 items, no tokens. But the collection is an empty collection, but it's there on the network, on the blockchain.
Yep. So looks easy, and we are ready to create tokens. Where is file? Create tokens. Copy from draft. In this script, we are using same library. It's our SDK, it's a standard library, our file with defined attributes, our NFT metadata file. How you remember it contains a bunch of attributes and link and seed to a PFS. Where is it? Oh, it's here. In this case, we are reading NFT metadata file for create tokens. First of all, we are getting signer, creating SDK instance, and parse NFT metadata file, and generate data for our token.
So take note, these first steps are like what you always do this when you're using the SDK, like create the new SDK, connect and so on to be able to, so take note, this is like the standard procedure for using the SDK.
In top of function, we can see 2 links to our method. One called create token, and another one create multiple tokens. First method allow to create only one, and second multiply.
That is, it takes one call to generate 10,000 NFTs. Sweet.
Yep, it saves a lot of time. How can you see token attribute should have address, collection ID, data, and image. image IPFS looks clear, but encoded attributes looks some strange because that value contain numbers. Why it's a number? In our collection scheme, we are using enum with values, and in token we should index of enum value defined in collection scheme.
So we're not replicating the same structure. We're actually calling the structure that we previously described in how the schema of the collection looks like for every NFT. Using indexes, yeah.
And that's all. We are ready to create a bunch of tokens. Oh, sure. We should add our scripts. Create tokens. Yes, not start script. Oh. Now we are waiting to generate a new block in blockchain where our data about tokens will be saved. Oh, all token generated. We can see that their collection ID. Oh, sorry, it's incorrect collection number. We have another one. I should fix it.
Mm-hmm.
And run our script.
So this just by chance, because we were, of course, testing this with a few models before that, it went through, but you would have gotten a mistake during this place if you try to input just any number or the wrong number, because it wouldn't be creating the correct, pulling the correct data for creating the collection. Yeah. So we've got 1404 or 1404 done.
Yes, it's correct. And after 1 to more minutes, we can see the tokens in our scan. Let me check. Oh, only 1, 2.
So was that 1 second per block read?
Yeah.
Yeah, here they come.
This works.
Great.
That's all. It's a very, very easy way using SDK to create collection and create tokens. And our new feature is create nested token.
Yes, here's the bonus part.
Right.
Okay, so yeah, let's nest. So in this case, Sergey is going to nest one of the created NFTs under another NFT. So in nesting, we actually have a limit to 5 levels of nesting, but vertically. But horizontally, you can nest as many tokens as you essentially want. And of course, the structure can be complex because it is a true binary tree. So actually a data structured tree. So you can have like branches with many sub branches and so on, but only 5 levels deep for now. It's a resource limitation set there. And there's nothing that actually prevents you from going further, but it makes sense to limit it at that point. So please continue, Sergey.
Thank you. In this script, we define some constants with collection ID and parent who token who will be parent and child. I'll send link to documentation in chat.
In this case, the parent is also the root because it is the first NFT at the top of the structure.
That's method have easy to understand arguments. It's only address and parent and nested token. Take attention, collection ID may be different. It means we can nest token from one collection to another.
Yeah, so completely different collections. You might have collection of hats and collection of shirts to put on a person NFT, but you can nest collections different NFTs or tokens from different collections under one collection. There is one clause that needs to be fulfilled. We mentioned it previously. It was that the one who's doing the nesting needs to be an administrator, declared as an administrator in those collections to be able to do to make connections between them.
In the bottom of a script, you can see what after nesting one token to another, we are getting token for read information about result. Let me run it. Create token.
So the idea behind how you're going to use nesting, if you're going to use nesting, is up to you, in the sense that you could use nest mutations, you could nest whatever you want. I mean, in whichever way you wish to organize the structure of the created NFTs, that's up to you.
How can we see one token nested to another, and child token have information about their parent? And that's all. I will send a link to repository with workshop scripts, and all who want can run it or modify it or use. And I'm finished. Thank you.
Thank you, Sergey.
Right.
So that's it from our side, guys. If anyone have some question, we're ready to answer.
We don't have questions yet, but if you want to continue.
I have a question. So regarding these links, can we post it in the Discord as well? Yeah, these the proceedings or the documentation for the hackers in the hackathon. Yeah.
Yeah, sure.
Like
I will take these links.
Mm-hmm.
We can share it on the Discord.
Please do. Yeah. So that anyone that took part can use it as reference.
Okay, just a minute. Okay, I have them. So you continue, Philip, or this is the whole
This
presentation?
is the whole presentation. Essentially, we've showed all the elements that I think just with all this is so sweet. Like you have all the elements that you need to complete the assignment. The thing is, it's up to you to use it in the most creative way you want. So that is why we left the assignment very open. Use any kind of idea you have. We mentioned, like, if you have an idea to use artificial intelligence to mutate the images in some way, if you want to compose them through some very complex way, if you want to implement aspects of some algorithms or anything that you might find interesting, we showed you the way how to construct the NFTs, how to go through the construction process of assembling the image of the NFTs. And we've also thrown in the presentation of how you nest them under each other. So even you can go even a level further, like you can nest, I don't know, videos or other NFTs that are related to that NFT or are mutations of that same NFT, or have another complete idea of how this can be done. This is all open to the hackathon contestants to play around, have fun, and simply explore and enjoy the thing, because this is what we wanted to kind of create an easy way to kind of go through it all and create it and mix it up and make the world a better place by doing a lot of things in creative ways.
Definitely. Yeah, I think it was really interesting. The way you show us today how to think and deploy new ideas in the unique technology. So guys, I appreciate your time, and this session will be is recorded and will be uploaded in the podcast Hackathon Latam YouTube channel, so teams can be able to watch anytime. Thanks again, and see you soon.
Thank you. It was a pleasure.
Okay.
Thank you.
Bye bye, Georgie. Bye bye, Sergey.
Bye bye.